Hey guys, welcome. Yeah, so I already showed you one method for solving this integral, and this time I'm going to show you a different method that is just as fun and efficient. Yeah? Okay, now some parts are going to seem similar. So to start, for example, we have the same start of writing x to the x as e to the x times ln of x. And then, just as we did before, we're going to use a series expansion for e, and so this here is equal to, I really prefer chalkboard over this, but anyway, we'll live. Okay, so now in the first video, I said that you could take out 1 over n factorial and write it in front of sigma. And as I said in that video, I was really tired, but you can't do that because sigma is adding over n. And one of you should have figured out that you can't do that. You should have written a comment about it. But anyway, yeah, since sigma is adding over n, 1 over n factorial has to stay to the right of sigma. Yeah? Okay. With that said, what we want is 0 to 1 dx, and we can write the integral after sigma as opposed to in front of it, right? Okay, now this is where this method is very different from the first method. Okay, what we're going to do here is we're going to say that u is equal to the negative of the natural log of x. Then notice that negative u is equal to the natural log of x, and then e to the minus u is equal to x. Furthermore, from negative u equaling the natural log of x, we see that it follows that negative du is equal to 1 over x dx, right? And from that, we see that negative x du is equal to dx, but x is e to the minus u, so that's minus e to the minus u du is equal to dx. Yeah? Okay, cool. So we are ready to substitute all that stuff over here. So we have n equals 0 to infinity of integral, and the limits of integration also change because our substitution, u equaling negative ln of x, is the same as u equaling the natural log of 1 over x, right? So understanding that, right, 0 becomes the natural log of 1 over 0, natural log of infinity, so that's infinity right here. And then 1 becomes the natural log of 1 over 1, that's the natural log of 1, which is 0. So we have this. And then clearly we have this here, right? X ln of x to the n is the same as x to the n and then ln of x to the n, right? So in it we have negative u to the n because negative u is ln of x, right? So we have negative u to the n from the ln of x to the n. And then we have the x to the n. X to the n is e to the minus u to the n. So we have negative u to the n, but we also in front of it have e to the minus u to the n, like that. Right? Furthermore, we've taken care of these two guys now. We have dx, which is negative e to the minus u du. So I'll write the e to the minus u du right here, but the negative in front of it I'll save to help us swap the limits of integration to seem normal. Yeah? Okay, cool. And of course we have 1 over n factorial, and as long as it's to the right of sigma, I'm able to write it in front of the integral sign like that. Yeah? Okay, cool. Now e to the minus u and e to the minus u to the n combine to e to the minus u to the n plus 1, like that. So I could get rid of this and just write du here. Yeah? Okay, cool. And this here is e to the minus u times n plus 1. So I prefer to write that. So e to the minus u times n plus 1. Okay, cool. And also, negative u to the n is, that is negative 1 to the n, and then u to the n. And of course, I still have du after it, right? Okay, we've made a lot of progress, but one more substitution will do the job. And this is that one more substitution. So this time let's let t equal u times, let's let t equal u times n plus 1, right? So t is this right here. That's t. Okay, so then dt is equal to n plus 1 du, from which we see that dt divided by n plus 1 is equal to du. And then we also see that t divided by n plus 1 is equal to u. So we bring all this and we're going to substitute in here in blue. Yeah, okay. So we don't need this, so we need this space. So, okay. So that means that blue is now what I'm going to write in red, which is, you think I should call my channel blue marker, red marker? I'm so funny. No, okay. 1 over n factorial. And then notice that like the switch from u to t doesn't affect the limits, because as u goes to infinity, so does t, and when u is 0, so is t. So 0 to infinity, right? And then we have e to the minus t, right? That's nice. And then negative 1 to the n, I could write right here. Negative 1 to the n. Okay? And then now we have u to the n. U to the n is 2t t to the n divided by n plus 1 to the n. It's 2t, no, t to the n divided by n plus 1 to the n, right? If u is t over n plus 1, then u to the n is t to the n divided by n plus 1 to the n. Okay, that's abundantly clear. And then du is dt divided by n plus 1. Ah, cool. So you see, this guy and this guy can combine. I could just write right there, right? And so I could get rid of this. And as a matter of fact, I could take the 1 over n plus 1 to the n plus 1 and write it in front here. Yeah, and I'm gonna do that and need space. So now what we have is the same as this. It's the same as n equals 0 to infinity of negative 1 to the n over n factorial, and then n plus 1 to the n plus 1 power, like that, and then integral 0 to infinity of e to the minus t t to the n dt. Now, I have a number of videos on the gamma function, but this right here, this is gamma of n plus 1. And if you watched my videos on the gamma function, you know the gamma of n plus 1 is equal to n factorial. So what I just circled, the integral, is simply n factorial. Oh, how convenient. Because I'd seen an n factorial somewhere else right here. Yeah? So what we have is simply this here, which is that, and then n plus 1 to the power n plus 1. Yeah? Cool. All right. Now, before we finish, let's do one more thing, which is let's let k equal n plus 1. Then our final answer can be written as sum, instead of n equals 0, we get k equals 1 to infinity, and then negative 1 to the k minus 1 divided by k to the k. Okay? Alright, I'm done. Bye.